Let's now talk about pointer arithmetic. A subset of arithmetic operators is allowed on pointers. For example, you can do plus plus, minus minus, and you can do both kind of plus plus and minus minus. You can do postfix plus plus, prefix plus plus, postfix minus minus, prefix minus minus. All these four are allowed on pointers. There are other operations allowed on pointers are you can add an integer value to a pointer, you can subtract an integer value from a pointer. When you add an integer value to a pointer, it gives you a pointer only, right? It moves the pointer certain positions ahead. When you subtract an integer value from the pointer, it again gives you a pointer and moves the pointer few positions back in memory. You can subtract one pointer from the other. When you subtract one pointer from the other, it gives you an integer value, which is the number of elements between two pointers. Let's understand these operations on pointers, these arithmetic operations on pointers one by one. So here is an example. I have created an array with 4 values 10, 20, 30, 40, and I have created a pointer variable ptr equal to arr. So when you do this, arr, the array name, gives you the address of first element in the array. So ptr is actually initialized at this location, right? The first element address. And I am assuming that we are running it on a machine where we have 4 bytes for integers. So 10 is stored in 4 bytes. That's why I've written these 4 things here. 1, 2, 3, 4 bytes here. And then 20 is stored using 4 bytes. And so are other elements of the array. They are all stored using 4 bytes. So ptr is here right now. When we do ptr plus plus, what happens is ptr is moved 4 positions ahead. It's not 1 byte increment. It's 4 positions ahead, 4 byte increment to the pointer. And you must have guessed it now. It depends upon the type of the pointer. If it is an integer pointer, then it's going to move ahead equal to the size of the integer. So if it is a double pointer, then it would have moved 8 bytes ahead because double takes 8 bytes, right? Since it is an integer pointer, it moved 4 bytes ahead. Had it been a character pointer, it would have moved 1 byte ahead. So if you see the output of this program, first we are printing star ptr. Since it holds the address of first element, we are going to get the output as 10. Then we are printing ptr itself. We get an address, right? We get a long address, and at the end we have 40. Now we are doing ptr plus plus. ptr moved here, it moved 4 bytes ahead. And now we are printing star ptr and ptr. Now we see that we got 20 because this now holds the element of 20 here. Now it's here, right? Holds the element of 20. And the value that we got for ptr is 44 at the end, 4 bytes ahead, right? That's what I said. It depends upon the type of a pointer. If say the pointer was a pointer to a user defined object, and say user defined object is a student object which contains say 100 bytes. If you do a pointer increment to such an object, your pointer is of type of student, right? You have created your own data type, a student, and you create a pointer to a student, and then you create ptr plus plus, then ptr will move 100 bytes ahead. So it all depends upon the type of object the pointer is pointing to. Here it is pointing to an integer, so it's going to move ahead 4 bytes. Here I have modified the program, and now I am using ptr minus minus. The purpose of this modification is to demonstrate the minus minus operator on pointers. When I do minus minus, the ptr goes back 4 positions, right? It was 44. Now when I did minus minus, it went back 40, right? So like increment, decrement takes you 4 positions back, 4 bytes back, and these 4 bytes are the size of an integer type of the pointer, right? Now if I print star ptr, I am going to get 10 again, and if I print ptr, I got this original position again. Let's now take a look at plus minus examples. So I have modified the program again, and now I am doing ptr equal to ptr plus 3. And then I am printing star ptr and ptr, and after that I am doing ptr equal to ptr minus 2. So what happens now, when I run this program, I am going to get an address. It can be any address. For my convenience, I have kept this old address. But when you run the program and again, you might get different addresses, right? Because the variables might be stored at new location every time you run your program again. So when I print initially star ptr, I am going to get 10, and I am going to get the address, any address, right? I have kept the same address here. Now when I do ptr equal to ptr plus 3, what happens is this pointer moves 12 bytes ahead. Why 12 bytes? Because it moves 3 objects ahead. 3 here means integer value means 3. You need to move 3 objects ahead. And how do you just decide the size of an object? It depends upon the type of pointer. It's an integer pointer. Size of an integer is 4 byte. I'm assuming 4 byte in this machine. So it's going to move 12 bytes ahead. 3 into 4. 3 objects. Every object is an integer. An integer is of 4 bytes. So when I print star PTR now, I am going to get 40, right? It was 10 here, now 3 objects ahead, so it comes here at 40. Now when I print the address, I am going to get 12 bytes address ahead. So C means 12, right? In hexadecimal, we have A for 10, B for 11, and C for 12. So that's why we get C here. And after doing this, if I do PTR equal to PTR minus 2, like addition, it moves the pointer 2 positions, 2 objects back, right? So 2 objects means size of an object is 4 here, object is integer here, right? So 4 into 2, 8, 8 subtracted from this, so we get 44, right? So we get the address is 44 and we get the value as 20 because from 40 2 positions back is 20. Here I have modified the program again, and in this modified program we are going to explain subtraction. So I have called this pointer variable name as PTR1 now, and PTR1 is again ARR like PTR, and we are printing star PTR1 and then we are printing PTR1, so we are going to get 10 and address of 10, right? Then we have one more variable PTR2 and we are initializing PTR2 as PTR1 plus 3. So we are going to get 40 and then we are going to get 4C, which is 12 bytes ahead of this, right? Because we incremented by 3, which means 3 into 4, 12. Now we are going to print this and we got this value, and after printing this we subtract PTR1 from PTR2, and this is something we are explaining in this example. When you subtract a pointer from another pointer, it gives you the number of objects between them, right? Not the number of bytes. The number of bytes between them are 12, right? But the number of objects are 3. And how do you decide the number of objects? According to the data type, right? It's an integer pointer. So 12 divided by 4 is 3. And please remember, you cannot subtract one type of pointer from the other type, right? You can subtract only similar type of pointers, same type of pointers. So both are integer pointers. That's how we could subtract, and we got the number of elements, number of integer elements between them. Please note that pointer arithmetic is useful when you have a pointer pointing to an element in an array. Using pointer arithmetic, you can quickly move ahead, quickly move back. You can quickly find out how many elements are there between 2 addresses. So pointer arithmetic makes a lot of sense when you have a sequence of objects, which is an array of objects, and you have pointer to these objects.